2.7, ionic compounds. This is a really important lesson. Um, well, first, what is an ion? An ion is a charged atom formed by gaining or losing electrons, and this typically happens when a nonmetal who wants an electron more rips an electron off a less stable atom. So all this means is that uh, obviously atoms can't want electrons, which is something that was really confusing for me when I was first learning chemistry, and people would use the term want. But no, atoms, they don't have a desire. It's more just about what happens. So, as we see here, we have sodium. And then sodium has this one electron that's just lingering on the outside. And a nonmetal has a space for that one electron. And what will happen is that the metal atom will cling onto the nonmetal atom, or the nonmetal atom will cling onto the metal atom and just rip the electron off because the nonmetal atom wants it more, doesn't actually want it more. It's just what happens because of something we'll learn later on in chapter 11. Um, or, yeah, I think it might be chapter 9, but that's what happens. A non-metal and a metal will always, or most of the time, form an ion. A cation is a positively charged ion formed when an atom loses electrons. So electrons have a negative charge. So once you remove that negative charge, you'll gain a positive charge. As we see here, the sodium atom goes to a positive sodium atom because it loses this negative thing. An anion is the opposite. A negatively charged ion forms when an atom gains electrons. And I don't have a model for it here, but something like a nonmetal, because the nonmetal rips the electrons off, will be negatively charged. And therefore, since it has an extra electron or negative particle, it will carry a negative charge. So polyatomic ions are ions that have atoms inside bonded to other atoms. So we have a few examples here, and that's ammonium and acetate. So as opposed to the sodium atom here on the previous slide, we see here that this is just one atom, or one atom, one ion. But we go to this page, and we see here that ammonium and acetate are groups of ions that carry that negative charge. So it's important to distinguish between a polyatomic ion and a monatomic ion, which I don't have here. A monatomic. It's just basically like a regular ion, just that it's one atom carrying that charge. An ionic compound is a compound formed from ions that are negatively and positively charged. So what happens is when the nonmetal atom rips the electron off the metal atom, the nonmetal will be negative and the metal will be positive. And so the metal will be a cation and the nonmetal will be an anion. So what happens is when there's a positive and negative charge, they attract each other. And they'll just come together and the opposite charges will just keep them there. And that's what an ionic compound is. An empirical formula is used for ionic compounds and is simply the whole small ratio of ions. And ions always basically have basically the same AMU. The differing mass of the electrons are negligible. So that basically means that the sodium ion didn't lose any mass. I mean, it technically did because of this tiny electron here, but it's not going to contribute to any weight, or should I say, it won't contribute a huge amount. It's going to be negligible. So, you mentioned here about the empirical formulas, and I'm just going to use hydrogen peroxide to describe it. We have hydrogen peroxide here. And this molecule will look like this, I believe. So the hydrogens are at the end here, and the oxygens are in the middle. We can just simply rewrite this. Oh, sorry, that's actually the wrong. I think I drew two water molecules touching each other, but this is what I think hydrogen peroxide looks like. I'm not too sure about the actual structure, But we see here that there's two hydrogens and two oxygens, but we can divide these subscripts by 2. And it's basically just going to be the simplest whole number ratio of atoms in a molecule. So we can rewrite this as HO, which will just be 1 hydrogen atom to 1 oxygen atom. That's it.